Hi everyone, I'm Zoltán Lehotsky from Lumbik Technologies Limited, and this is a practical introduction to TortoiseHg. We at Lumbik are an open source software development company, and we mainly work with the Orchard content management framework. Now, internally, we mainly use TortoiseHg, and through that Mercurial as our source control. So this will be a fairly short introduction on how to use TortoiseHg every day in team development scenarios. It will be very practical, so I won't explain a lot of concepts, just a few, and even those not very much in detail. So if you want to really understand all of the concepts, please do look at some of the more in-depth tutorials out there. So we will start with setting up TortoiseHg. Now, I mentioned we mainly work with Orchard, and we have an Orchard training website called Orchard Dojo. And in that Orchard Dojo, there is a Dojo Library. The Dojo Library is an open repository of all kinds of Orchard-related goodies. But there is also a development environment advices page, where you can, among others, also see some mercurial and TortoiseHg tips that are generally interesting. For example, here is a mercurial.ini sample that you could use to set up your TortoiseHg instance. Now, this contains some very common configurations so you can really kickstart on using Mercurial and TortoiseHg. First of all, you can specify your username, the default username to use for all repositories. Well, there are some useful extensions that we think is useful to have enabled. And if you use Mercurial keyring for authentication, then all this is very much advised as well. The keyring extension is an extension that stores your passwords. So every time you use a password protected repository through HTTPS, the keyring extension will store your passwords instead you having to type it in every time. And for that to work properly with subrepositories, and we will look into subrepositories later, you need to set up these prefixes for all the source control providers you use. By the way, we will look into using Bitbucket. And last but not least, here are some general settings for TortoiseHg that you may want to use as your default. Now, if you download this mercurial.ini file, you can place it into your user repository. So once you have TortoiseHg installed, you will have a mercurial.ini file in your user repository. So this is the standard user repository in Windows. You can just overwrite your mercurial.ini that was created by default and start using our defaults from the beginning. Still in the Dojo library, there are also some source control best practices. By the way, the links to these pages will be in the description of the video, so you don't have to copy it by hand, of course. And these source control best practices are generally interesting again, not even just for Mercurial, also for Git. I won't explain all of these, so please take some time to look through all these best practices that we have compiled here. Now, what we need to use Mercurial and TortoiseHg. Of course, first we need a repository. Now we will use everything as we would do in a team, in a development team. So we won't use Mercurial just with local repositories, but we will create a remote repository first on Bitbucket. Again, I won't explain concepts like repository and what a distributed source control system like Mercurial is, so please take your time to look into all the concepts, all the basic concepts yourself. So in Bitbucket, I've created a repository. It's called demo repository, and it's reachable under this URL. First, we need to clone this repository so we can work with that locally. So on Bitbucket, when we use HTTPS to access the repository instead of SSH, it's very easy. We just have to copy the full URL and now copy it locally. So I will go to the desktop and I have Zoltan's clone here. By the way, we also have an Alice's clone that we will use later. And the right click brings up the contextual menu, and under TortoiseHg you will find the clone menu. Here you have to copy the URL and hit clone. Depending on the size of the repository, this can take some time, but here it was quite fast. So here is the clone of our repository. As you can see, there is nothing here yet. The repository is actually empty. So this is what you will see first when you create a repository and clone it in TortoiseHg. By the way, this is the TortoiseHg Workbench that we are using. This is basically the main interface of TortoiseHg, and here you can see all the commonly used features of Mercurial that are accessible through the graphical user interface. One note here, we also have a so-called repository registry here on the left. Basically, this is really a registry for all of the repositories that you opened on your computer previously. This is of course customizable. You can create new groups like Lombic and etc. Here, new group. So this comes handy if you like to open repositories from inside the workbench instead of going there using Windows Explorer. So here is our clone, and as you can see, by default, Mercurial would use the default branch. Now again, I won't really explain concepts like branching in detail, but just as a very simple summary, branches can represent different passes in development. So what we commonly use at Lombic, and this is also a common convention among development companies or development teams, is that there is the default branch that is for releases. So everything that we release will be a commit in the default branch. But we don't do daily development in the default branch, but rather in the dev branch. So let's see how all this goes, and let's add something to our repository now. And we go back to the desktop, and here is the folder of our clone that contains nothing yet. As you can see, it's just a .ag folder that's created by Mercurial, used by Mercurial. We don't have to care about that. And I will now add something to the repository. So let's add some algorithm, since we are a software development company. But we could also add some picture or whatever. So you get the idea. We have some files now in this folder. Now we have to go to the workbench and commit this to the repository. The committing is basically a way, or is the way to take a snapshot of the content of that folder that we have there, and this is the first step in actually doing versioning of the files, and also the first step in sharing these files in our repository with our team members. So when we hit refresh here, all of our files that, all of our changes that we have in that folder will be shown. So as you can see, here are our files. By the way, there is also a way to automatically refresh this window, but it's not very performant on slower machines and big repositories. So if you want to have that, you can enable it. Anyway, here is the commit window, or a commit dialog, or a commit part of the window. And here's the branch selector. Here we can select which branch to commit to. Again, it would go to the default branch by default, but as I mentioned earlier, commonly we use the dev branch. So I will open a new branch here. We'll call dev, and this will be our initial commit. Commonly we use initial commit as the commit message for the first commit. Let's add some more description. And let's not include the picture yet. So as you can see, of course, we can select which files, with which changes from which files we want to include. And we can hit commit. Yes, and we want to create a new branch. And yes, we want to add the new files. So now here we have our first commit. And as you can see, it went to the dev branch. Now again, commits are basically snapshots of repositories, and how this works we will see in a minute. And next, let's add picture, and this will be our second commit. Alright, so now we have everything committed, and here is our folder. So let's see what commits actually do, and what does it mean that they are snapshots of this folder stored in the repository. If I would want to go back in time and select a different snapshot of our folder, I can update to a change set. So here we can click right click here on a change set and update to that change set. This update will basically change everything in our local directory to the state that was stored in that change set. So if you go to the folder, you can see that there is no picture.jpg here. That's because it was just added in the second commit. So the first commit is a snapshot where there is no picture.jpg yet. And by updating, we selected to update our working directory, as it's called, to the first commit. And we can go to the second commit to restore everything. Now, regarding committing, there are also some interesting features in TortoiseHg. Let's open this algorithm. But with Notepad, and write something here. Let's refresh the folder or the commits window again. You can see we have we have the changes indicated here. Now we could add some more code. If I hit refresh, this will be shown as well. This is a classic diff view. So if you have seen diff tools like vmerge, it's very similar. So let's commit this as well. Alright, let's pretend that now we have a release. So, as I mentioned earlier, commonly we use dev branches for daily development, and more branches of course, but just as a start we use a dev branch at least, and we use a default branch for releases. So let's pretend that this code now here is awesome and we want it to release out to our customers. Commonly in development teams and companies, there is also a continuous build or a continuous deployment setup that will do something special depending on the branch. So, for example, the dev branch could be built on every commit and tests could be run. And the default branch could build a deployment package or ship some artifacts to the customers or something like this. So a lot of things can be automated if you use some conventions, even in source control. So again, let's pretend that we want to do a release. But there is no default revision. So what can we do? Commonly we would update now to the default revision and merge everything from dev to the default, but we don't have a default yet. So unfortunately we have to first open it. And again, it's the same thing with opening a default branch. So it's just default. And to open a branch, you don't need to commit anything. You just can open the branch with an empty commit. Alright, so now we have practically shipped everything to our customers. And if we do some more work, we will ship it again. But first, and this will be emerging, but first let's see what happens if others are also working on our repository. Because everything that we have done until now was happening locally. If you remember, we have this repository here on Bitbucket. It's stored also on Bitbucket servers, but we haven't synchronized my local clone with Bitbucket servers yet, so we have to do something about that. And this feature or this command that is used for such synchronization is called push. Actually, there are two commands. One is called push, and here is the button for that, and one is called pull. Push will basically push the whole repository that you have on your machine to the remote server. Well, of course, not the whole repository every time, but all the changes. In our case, because the repository was empty, every commit that I created here will be pushed to the remote repository. So let's do that. Pulling would be the opposite operation. Pulling would pull in all the changes from the remote repository and make it appear here. So I've did the push. Let's refresh on Bitbucket, and as you can see, my commits now appeared. That's great. And now we have shared the repository, what we have worked on locally, with our whole team. But what if there are multiple people working on the same repository? Because then things get a bit more complicated, and we have to care about what the others do. So let's see how this works. Let's pretend that our colleague is Alex, and she has the repository already cloned, but it was a previous clone. She has cloned it some time ago, so it's empty yet. So what Alice has to do now is to do a pull. Basically, every time when you start to work on a repository that is used by multiple people, it's good to do a pull first, so you can see if anything changed there. As you can see, Alice now pulled in all the changes that we have done previously. So to update her working directory, she will do an update, but not on the default, because that's just for releases, but on the dev. So let's do an update. And if you take a look at Alice's clone, it has the same data than Zoltan's clone. So not a big surprise. And now let's pretend that Alice and Zoltan are working side by side. So let's see what happens then. Let's pretend that the algorithm and fix something. And she will commit the changes to dev. Now Zoltan, who is working on something else, doesn't see this yet, but he will also change something. And he will add a second algorithm. And he will commit that as well. Oops. Now at this point it's interesting because nobody has pushed yet. But let's pretend that Alice was first here, and she has already pushed her changes. So the fixes to algorithm are already on the server. Now Zoltan in the meantime committed algorithm 2, and he wants to push that. But first he recognizes that he actually made a mistake. As you can see, I've committed to default. Now this is again something that could happen during development, but there is a very handy feature in TortoiseHg that you can use in this case, and it's called rollback. The rollback undo feature will roll back the last commit that you have made. So basically that commit will just vanish from the history. Now be advised that this is only good for changes that you haven't pushed yet. So this was a lucky thing because I haven't pushed yet. Now we can undo. Alright, the commit was undone. As you can see, it's not here anymore, but the changes are still here. However, before committing this algorithm, we have to switch to the dev branch because now we are on the default branch. If I would hit or set this to commit to dev, this will result in something quite funny because we would restart the dev branch from this default commit. But this is not what we want. We want to first go back to the dev branch and commit algorithm 2 there. Now, if I try to update here, there is a warning that we have uncommitted changes, the changes to algorithm 2. We have to do something with that. Now, we could discard the changes, but this was a lot of work, so we don't want to do that. Instead, we can shelve it. The shelve is basically a storage of 5 diffs in TortoiseHg. So you can put things from the working directory that we have on the left. So, for example, our algorithm 2 changes, and take those and put them on the shelf. Here is just one file, so we could select move selected file to the right, or we can select move all files. Now the algorithm 2 changes are on the shelf, And the shelf is not our working directory. So if we close everything here and refresh, there are no changes anymore. This is because our algorithm 2 changes are now in the shelf, not in the working directory anymore. And this means that we can simply update to dev. Alright, let's restore the changes from the shelf. So open the shelf again and pull back everything from the shelf. And as you can see, now we have algorithm 2 back. So let's add that. Oops, there's just the second version, not the third yet. And let's do a commit. Alright, so that's good so far, and now we want to push. But this won't be so easy because Alice was quicker. And as you can see, pushing fails. Mercurial and or TortoiseHg is quite good with error messages, as they are quite helpful. As you can see, here is a hint already, but down on the log we can see that the push failed because it would create a new remote head on the dev branch. Basically, head is always the latest commit in a specific branch, and now if we would push this, it would mean that we would have 2 such head commits on the dev branch, since there is already one from Alice, and we would push this. This would be quite confusing. You can actually do that in special scenarios, but generally this is not what you want, because you just want to have one single head for every branch. So if you tell somebody update to the dev branch, they will know which change set to update to. There will be no 2 or 3 dev head change sets, because that's really confusing. Anyway, here we have the hint. The hint says that we should pull and merge probably. Well, we can do that too. So let's do a pull. And now if we pull, we can see the changes by Alice. And as you can see here, we have 2 heads on the dev branch, and this is indeed quite confusing, so we don't want to share this with our team. So what can we do? Well, we have at least 2 ways to solve this issue. Let's try the first one that was advised by the hint, and let's do a merge. A merging is basically an operation between 2 branches. When merging 2 branches, we will union the content of the 2 branches. So let's hit merge here on the commit by Alice. Let's commit the merge itself, and now as you can see, we have merged these 2 branches, these 2 dev branches, into a single one, and now we are able to commit the changes. Alright, let's pretend that this is good enough, and now we want to have a release again. Now we will do a merge to default, because this was a merge that we didn't really want to have, because there was no semantics behind it. But now by merging to default, we really express that we want to have a release. So to do a merge to default, let's update to default and merge everything from dev. That's right. And once we push, everything is released. Now, branches, of course, are not just good for releases, but commonly branches are also used to work on issues or tasks. So if you work on a specific task, do that in a branch, in a custom branch, like issue/issue ID. This is a common practice, because when you work on a branch, you won't interfere with the work of others, and you can keep the dev branch always in a state where it is possible to release it. well, ideally. And once you are done in your branch, you can merge it back to default. So that was the merge operation. Now go back to dev and let's try the scenario that we had with Alice before, and let's see some other solution instead of such a merge. So again, do something in Zoltan's clone. We will do some fix in algorithm 2. And do some more fixes, but this time let's fix in algorithm 1. Of course, this is a demonstration, but naturally keep in mind that it's good to use descriptive commit messages. Well, of course, this is very descriptive. All right, and now let's do it again in a way that Alice will push first. So let's not push this yet. We have done 2 commits, one to algorithm 2 and one to algorithm. And now let's go to Alice's clone, and we will here also change something in algorithm. So remember, this is a file that we have that Zoltan has already changed. And so let's commit that as well. Alright, and let's also push that. And again, we see the same error that we have seen before. We have the pool. We see all the changes that Zoltan has made. Here we see the merge that we have had before. And now we have to fix that. But we don't want to merge again, because as you can see, all this gets a bit complicated. We have this graph here that displays how the branches run, and it's quite painful to see all these merges from dev to dev, especially if you have more than just 2 team members. So let's do something else, and what we will do is a rebase. Rebase is an operation that in this case would basically take this commit of ours, where we fix the nasty bug in algorithm, and move it above this dev commit. So there will be no merge. It will appear that everything happens in a sequence, but as you can see, in reality this wasn't the case. So to do a rebase, we have to update to the change set that's already on the remote server. So let's update to that, and we need to rebase our yet unpushed change set with the nasty bug fix on top of this. So let's right click on our commit and hit rebase. Basically everything on the default here is fine for us, but once you get a bit more familiar with all this, do take your time to look through all the options. So now you can see we have rebased our commit on top of this commit. Everything appears as it would have come. Everything appears as the commits would been done sequentially. And if we update to our commit, we now have everything in our working directory. We see algorithm 2, algorithm has our fix, so everything looks great. Let's push this. But now Zoltan will have some issues again. So let's go back to Zoltan's clone and try a push. And of course, it will fail. So let's do a poll. Yes, here we have the change set by Alice. And let's try the same trick. So update to this change set. Take our change set and rebase them on top of the 10th revision. By the way, as you can see, here are revision numbers. These are just the index of the different commits. By the way, the revision numbers are generally not a good way to reference or to talk about a specific change set, because the revision numbers can differ between different clones of the repository. Since, for example, as you can see, in Zoltan's clone we have 10 revisions, in Alice's clone we have 8, but this is probably a bad example because Zoltan's changes were not yet pushed. Anyway, you can keep some change set just local, so they are not pushed, not shared with others, but still they will count into the revision index indicator. But rather, there's a better way to identify a specific change set, and that is called a hash. Because if you do a right click and copy hash, I will just show it here. We'll show you the hash code of a specific change set. And now if you want to tell your colleagues that check out this change set and, I don't know, review my changes, is the best to share the the change set's hash, because then they can search for it and it will be very direct to look for the revision. So back to our issue, we have to rebase these two commits on top of the commit by Alice, and we can do that. So rebase will work for multiple commits as well. You just have to select the first commit. So let's do a rebase and close, and everything worked. Actually, yes, update to here, and let's see what's in algorithm. Now, here's an interesting thing. Remember that as Zoltan, we modified algorithm and added fixes, and as Alice, we also added some fixes. And as you can see, both of these fixes are indicated here, because although in the background we worked on the same file simultaneously. Mercurial was intelligent enough to merge the changes automatically. So most of the times when such simultaneous edits happen, an automatic merge will be possible, but sometimes there will be a merge conflict, and then it will be basically offered to you to do the merging of the code files or the files by hand, because that will be a case when Mercurial can't figure out how to do the merge automatically. But in this case it was easy enough, and as the result we have the beautiful automatically merged file that we wanted to have. And now let's do the push. And now everything worked. That's great. One more thing related to committing, pushing, pulling, and everything is rename. As you can see, we have, or as you have seen, we have these 3 files that we have changed a few times, and there is algorithm that we changed many times. Now, if we hit right click and, for example, file history here, we will see all the changes or all the commits that change this file. So it's a nice way to track where this file was changed. There is a bit more complicated way of doing this. There is this file history annotate option. Now this will display this separate window, and again here we will see the changes of the files. We can select the diff view here, so we will see which lines were added and which lines were changed. Or we can use the annotation view, where on each of the lines of the file we can see who changed it and in which revision. So this is a great way to see how a file was modified during the history of the repository and who did specific modifications. But for this to work, we need to keep track of files even when they change their name. So let's do that, and let's go to our clone and change the name of algorithm to super algorithm, because algorithm 2 is just something conventional, super algorithm is something super. And let's commit this change. As you can see, Mercurial sees that algorithm.cs was deleted and superalgorithm.cs was added. However, we know that this is not true, because in reality superalgorithm was renamed from algorithm. So we need to tell Mercurial that this was not a remove and add, but rather just a rename. We should right click here, and we could do that manual step by telling Mercurial that superalgorithm was renamed from algorithm.cs, but this would be quite painful with a lot of renames here. Instead, we can just let Mercurial detect the renames. This is configurable, and this feature is not always bulletproof, but works most of the time. Here you can select which files to check for. You can use this here to set how similar the files should be to be considered a rename. And let's hit rename. As you can see, the rename was detected, so that's great. Let's accept the matches. Alright, and this was it. When a file was renamed, Mercurial will color it differently. As you can see it in green. So now Mercurial sees that this was just a rename and not a removal. So let's add the commit message about this. Alright, and since we used the rename feature, when we check the history of super algorithm, well, for example here, we still see the full history. By the way, this same window can be reached from Windows Explorer as well. Under the TortoiseHg menu, we have some other items like revision history, and here is everything again. So that was basically everything related to push, pull, committing. We have seen what to do when somebody else has pushed to the repository before us. We have also seen an example of a merge happening. A file merge happening. We have seen branch merges happening multiple times. That was very exciting. And finally, we will see how to use subrepositories. Now, what are subrepositories? Our repositories here are quite simple in the sense that we just store a bunch of files in them. But what if we would have a class library, for example, in another repository, and we wanted to use that class library in multiple projects, and we wanted to share the full source of that class library between these multiple projects? Now, of course, we could just take a copy of that class library source and copy it here. But since we are using source control, we should do something better. And that better way is to use subrepositories. Subrepositories are just ordinary repositories, ordinary mercurial repositories that are used as a subrepository of another repository. So we put a repository inside a repository. And again, every repository here is a normal repository. So every repository can be a sub-repository as well. It's just about the way we handle them. We also have a sub-repository sample here. It's another repository on Bitbucket that's called demo sub-repository. Let's pretend this is our class library, or this is anything that we want to share between multiple projects. To create a subrepository, we should instruct, or to use subrepositories, we should instruct mercurial somehow. And that instruction is with a file called .hg sub. I have an example here, so let's move it to Zoltán's clone, and let's take a look at its content. An hg sub file is very simple. It's just some lines of passes where a specific subrepository should be stored, and the second information in such pairs is the URL to the repository. So as you can see, we will clone this demo subrepository to this path. And if you would have multiple subrepositories, it would be just about more lines. So there is nothing complicated here. So let's close this. We will have our subrepository here under the indicated path, but we don't have to clone it separately. We can just go back to TortoiseHg Workbench, refresh, and TortoiseHg will detect that there's a change to the HG sub. Now there is nothing yet, but let's do a commit. It's a subrepo with a capital S because this is its name, of course. Let's do an add, but we have a new subrepo, so we have to do something about this. And now will the magic happen when we update. Our subrepo appeared here, and now we can open this. So it appears similar to file changes, but it's distinctly different. We can open it, and we have another tab now here for that repository. That repository actually has some content. So if we do a pull, we will see what's there. There are some commits, so we can actually update to a change set of this subrepository. Because the relationship between such subrepos and top repos, let's call them as such, is quite simple. The top repository doesn't store anything about the subrepo, just the hash of the change set that the subrepo is currently updated to. So if we update to this change set of our subrepository, actually there is a secret algorithm here. So not just an ordinary or a super algorithm, but this is a secret algorithm. Very interesting. Now we have updated this repository to the first change set, not the zeros, but the first change set. If we go back to our top repository, we can now commit this state. And again, this state that we have in this change set here now will describe that we have a subrepository in this top repository that is updated to the first revision. So let's add that. We can also push it. So subrepository states are also shared through remote repositories like everything else. And if we go back to our working directory, you can see that this subfolder for the subrepository was automatically created for us. and here is secret algorithm. Now I guess you would die to see what's in secret algorithm, but I won't show it to you. I'm just kidding. Okay, maybe this is another algorithm and the real secret algorithm is somewhere else. Anyway, we have our subrepo here under this path, and let's change something there. Let's go back, let's add for example a second secret algorithm. Okay, and let's do something here as well. Let's add an algorithm that uses that secret algorithm. Maybe this should be capital as well. I'm not good with these language rules. And CS, because it's C#, of course. Let's go back and hit a refresh. As you can see, our change in the top repository is indicated, but somehow we don't see the change in the subrepository. Actually, I'm not sure when changes are indicated here. I think subrepository changes are only indicated when an already tracked file is changed. If you add a new file, then the change is not tracked, is not shown, like we have did with secret algorithm too. So let's refresh now, and yes, now we have it indicated that the subrepo has changed as well. By the way, here in the repository registry, there is now this this little UI that shows that there are subrepos under our repository. By the way, even your subrepos could have subrepos, so this can go indefinitely. So let's select here everything, and let's add the commit message that implemented secret algorithm 2 and commit. Alright, but this is no good because we have to commit the subrepo as well, and this is quite natural because the subrepo is a different repository. We have changed that, so we have to commit that separately. So let's commit everything here. Oops, 2. And again, everything works here as with a normal repository, so we don't have to do a single commit. We can just commit the secret algorithm to 2 changes, and we can separately commit the secret algorithm changes. Yes, we could also close this, and now we can commit everything in the top repository. Yes, and push. Everything is working fine, and now everything is indeed pushed. So working with subrepositories is not quite hard. It's a bit more complicated because every time you change something in the subrepository, it's the best to also commit it to the top repository. Of course, you don't have to do a commit in the top repository for every commit in the subrepository. As you have seen in our case here, there was also 2 commits in the subrepo, and I've only did a single commit in the top repo to include all the changes. But it does add a bit of complexity, so that now you have to manage 2 repositories. And now if you have 2 projects where this subrepo is shared, now you have 3 repositories to manage. So it's a bit more complicated, but there are a lot of advantages, since you don't have to copy code. That's almost always bad, and everybody can just keep using source control. You don't need to set up some packaging service to share sources. Although for artifacts, so to share binaries, a packaging service like NuGet would be better, of course. So that was it. By the way, so I will also wrap it up now. You have seen basically everything that's very important for everyday TortoiseHg usage. There are, of course, a lot more to this. There can be a lot of edge cases that you will probably encounter and you need to solve. There are a lot more features in both Mercurial and TortoiseHg that I haven't shown, of course. So do try to learn more, but I hope this was enough to get you going with TortoiseHg and Mercurial. So thanks for watching. Have a nice day.